The first big Python programming concept that we're going to talk about are variables. When you think about programming in software at a high level, it's all about manipulating data. For example, if you create a computer game, then you'll need to track the player's score, the number of lives that the player has, and what level the player is on. Of course, all this data changes over time as we play the video game and the program runs. So where do you, as the programmer, store this data and how do you track it? The Python programming language has a very convenient solution. You would store the game score in a variable. What is a variable? A variable is just a container for data. The important thing to understand about Python variables is that they both have a name and a value. For example, if I wanted to track my age inside a program, I can simply create a variable called myAge. MyAge is the name of the variable. But because myAge is a container for data, I can also give it a value. So I can stick the number 32 inside myAge. In programming lingo, this is called assigning a value to a variable. Now, as time passes and our program runs, we might need to update this variable. And we can do that simply by updating the value inside myAge with a new value. So we can replace the value 32 with the value 33. Now, the question is, what would this look like in Python syntax? Inside the Python intro notebook that we created, we're going to create a variable called myAge and give it a value just like this. MyAge equals 32. This name, myAge, is now how we can refer to the number 32. To display the value inside the myAge variable below the cell, I'm simply going to write print myAge. Hitting Shift-Enter on the keyboard will evaluate the code in the cell and then display this value contained inside the myAge variable. Now suppose our program is running and we need to update the value inside this variable. We can change this value of myAge simply by assigning a new value to it, say with myAge equals 33. If I write print myAge now and hit Shift-Enter, we'll see the value 33 printed out. No surprises there. Now variables are super handy because you can do calculations with them. For example, if we write print myAge divided by 3 and hit Shift-Enter, we'll see 11.0 printed out below the cell. Also, we can take these two concepts that we just covered and take it up a step in complexity. Let's say we want to update the value of myAge like this. MyAge is equal to myAge plus 1. Now, if it's your first time learning to program, this line of code is going to look very strange. But what's going on is that we're taking the previous value of myAge, namely the value 33, on the right-hand side of the equal sign, and then adding 1 to it. With that equal sign operator, we are storing this new value, 33 plus 1, inside of myAge on the left-hand side. In other words, we are overwriting the previous value stored inside the myAge variable. If we write print myAge now and hit Shift-Enter, we'll see our value update to 34. So let's do a quick exercise on using and manipulating variables in Python. As a challenge, can you create a variable called restaurant bill and set its value equal to 36.17? Then create a variable called service charge and set its value equal to 0.125. 12.5% seems to be the standard rate that restaurants suggest as a tip in London these days. Finally, print out the amount of tip below the cell that you would need to add to the bill. I'll give you a few seconds to figure this out, so pause the video. Okay, so here's the solution. For part 1, we'll write restaurant bill is equal to 36.17. For part 2, we'll write service charge is equal to 0.125. And for part 3, we'll write print, parentheses, restaurant bill times service charge. When I hit Shift Enter, I'll see that the value of the tip is 4.52. Now, all that's left to do is asking the waiter if the restaurant is pocketing the money or if the tip really does go to the staff. Now, one thing that could happen to you at this point is that you've made a typo. In programming, everything is case sensitive, and if our variables' names didn't match exactly to how they were defined, we're going to get some unexpected errors. For example, if this capital B in my print statement instead was a lowercase b and we had hit Shift Enter, we would have gotten the following error, name error. Restaurant bill is not defined. And this is because this restaurant bill and this restaurant bill are considered to be completely different entities. So you want to make sure that you never have any typos in your variable names. The same, of course, is true if we miss out a letter. So for example, if we wrote service charge instead of service charge, then we would get exactly the same error. Our variable is not defined. In other words, Python can't find something that matches this name. So let's put that R back where it belongs. Now that we've learned a thing or two about Python programming and variables, let's revisit the code that we wrote when we were estimating our movie revenue. Since I saved my previous work in a Python notebook and added it to the ML projects folder, I'm just going to open that now. Now, even though this code is a little bit more complex than what we have written just now, can you spot the variables in this piece of code? Now, there's actually quite a few, and you'll notice that the variables are often to the left-hand side of an equal sign. So for example, data is a variable. The capital X is a variable. The lowercase y is also a variable. All of these variables are holding on to data. But in contrast to the variables my age and restaurant bill, these X and Y variables are not holding on to a single value. They are holding on to lots and lots of values at the same time. And I'm going to show you guys how that works in a little bit. But before I do that, let's talk about another key concept that we need to understand when working with variables, namely data types. In machine learning and programming more generally, we'll be working with different kinds of data. We'll be working with text, decimal numbers, tables of data, columns of data, images, sounds, video, all sorts. And a programming language like Python will categorize this data. In other words, different kinds of data, like text or decimal numbers and whole numbers, will have a different category. In other words, they will have a different data type. Now you can think of data types like this children's toy, where you have to fit the right shape into the hole. So for example, when you try to put a decimal number somewhere where Python expects to have a string, you'll often find that you have a problem. And this makes sense when you think about it intuitively. Say you have some Python code that makes a calculation. Say you're adding two things together. If those two things are numbers, then you're good. 5 plus 10 is 15. But if one of those things is another kind of data, like, I don't know, a home address, you have a problem. Your program will crash, or it's going to do something very unexpected trying to evaluate 5 plus 21 James Street. It doesn't make any sense. Now, for the most part, Python will actually take care of the data types behind the scenes. So it's not something that's kind of at the forefront of the programming syntax of the Python code. But let me show you how you can actually see the data type in Jupyter Notebook. Because we can ask Python what category something belongs to by writing type, parentheses, and then putting something between those two parentheses. So for example, if I write type 33 and hit Shift Enter, the type of this whole number is int, int. int stands for integer, which makes sense. But there's also quite a few other types with maybe less intuitive names. So let me introduce a couple of them. If we write type 33.6 and hit Shift Enter, we get to see that decimal numbers are classified differently. Decimal numbers are classified as floats or floating point numbers. Floating point numbers are the type that you'll usually be working with every time you're dealing with numbers that have a decimal point. Now let me show you what the type for text is called. So I can write type, and then between the parentheses, I'm going to open the single quotes and add my name. When I hit Shift Enter, I can see that type for text is called str, and str stands for string. The word string is just computer jargon for a piece of text or a sequence of characters. And the way that you can tell that something is considered to be a string is by the fact that strings are always surrounded by either single or double quotes. And Jupyter Notebook is actually also very helpful with the syntax highlighting, so that the Python code that is considered to be a string actually has a different color. So in this case, the string is marked as red. Let's take another look at the Python code that we wrote previously and see if we can spot a string. Here we can see that when we were writing pd.read_csv, open parentheses, the value that we specified between these two parentheses was a string. It was a piece of text marked by the single quotes. And the same is true for the column names, production_budget_USD. And it's also true for the X label on our graph, and all the other parts where the code is highlighted in red. Okay, so far so good. We've just introduced you to a whole bunch of new programming jargon. Variables, data types, int for integers, float for decimal numbers, str for pieces of text, or strings. But how do data types relate to variables? What's the connection between the two? Well, if the data has a certain type, then so does the variable containing the data. Because after all, a variable is just a container. Now, for example, let's see what the data type is for the variable my age. So I can write type, and then between the parentheses, I'm going to supply my age and hit Shift Enter. And here we can see that because my age holds on to whole numbers, the data type of the variable is also integer, or int. Now let's take a look at the data type for restaurant bill. And I'm sure it's no surprise that because restaurant bill is holding on to a decimal number, 36.17, it's of type float. If I was to create a new variable called my name and set it equal to the string Philip, I can write type my name, hit Shift Enter, and I can see that the my name variable is a string. Now let's take another look at the notebook where we ran our regression. And let me ask you this. What do you think is the data type of the variables data, capital X, and lowercase y? This is the mystery that we're going to be exploring over the next couple of lessons. I'll see you there.